Hello and welcome, guys. So we are going to start this module on engine room pipeline diagrams, where we are going to study in details all the components and the diagrams in details which are coming in the engine room pipeline diagrams. So here we see this is based on one of the vessels pipeline diagrams. Okay, this is from the HHI shipyard. So you see it is Hyundai shipyard. Okay, Korean built vessel. Okay, LPG carrier pipeline diagram in engine room. We can see this. So index, we can see there are certain things that we are going to discuss in the index.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
Okay, there is a plan history, there is ship's particulars, symbol list, pipe standard. So when we are starting, we will go with minute details. So we will study from the small symbols that come in the pipeline diagram, then what is the pipe standards, and then we will go into these many pipelines as they are shown in this index list. Okay, so in this particular video we are going to discuss about the symbol list. We will start with the symbol list. Okay, so before starting that, we can see there is a history of this diagram. So this was originally made in January 2022. You can refer to your vessel's diagram and you can come to know where the revised diagrams came in. So first revision was done in March 2020, then a second revision was done again, revised for construction. So they were revised, and these are the revisions. R100 means revision. So when you see in your diagram R100 or R something, that means that is a revision. Okay, abbreviation table, if you see, OC is for ship owner's comment. Okay, owner's comment. CC is for class comment. Okay, so how does a diagram come into picture? An engine room pipeline is approved. A ship owner applies for the pipeline diagrams with the class. Okay, the yard gives the diagram to the owner applies to the classification society approves the diagram as per the rules and regulations of the SOLAS and MARPOL norms and the other norms that the class rules apply to, and as per those rules the pipeline diagrams are approved. So you can see here the first approval was given by ship owner. So yard made a diagrams, gave to the ship owner gave an approval. Okay, January 10 the yard submitted this diagram and it got the approval in February 2024. Sorry, February 24. So 1 month the owner took to give its comments. So you can find these comments as OC mentioned somewhere in the diagrams. Okay, then the class came into picture. So owner sent it to the class. Okay, so the class also sent it back after checking to the yard on March. Okay, so they took their time to give their class comments. Okay, or any modifications in the pipeline they see or they think that it is required as per their norms, classification rules. Okay, and then the ship owner's approval was given in this one revised diagram, and then class approval was given in this revised diagram. Okay, there is something called MR, like maker's recommendation. Like say OWS is made by some maker. Okay, so as per the maker recommendation, they wanted some valve to be fitted at some place. Say a three-way non-return valve should be fitted in the outlet of the OWS in the discharge pipeline. This is as per the maker's recommendation. So they will write it in the diagram as MR. So the valve has been fitted or some pipeline or some modification has been done as per the maker's recommendation. Then say there is a design improvement. Say the old design of the machinery or the OWS or say any machinery has been replaced and new machinery has been installed in that, and design have been improved, and thereby pipelines have been changed due to the design improvement. So they will be mentioned as a DI. Okay, change in pipelines as per the design improvement will be mentioned as DI. Okay, and builders specification, BS is builders are the yard people. So as per the yard, if any pipeline is specified, say the diameter of the pipe is as such as per the builder's specification, so they will be mentioned as BS. One also important thing is this one. So in most of the diagrams you will find this P1476 to P5086. So this is about the diagrams are, so in all these diagrams are from, you can see 14 to 50. So the page number is P14 and this is the connection number. So the pipelines have also got a specific number. Okay, so as you are seeing this, so the specific pipelines in this page number, say there is a page number 14 and there is a pipeline indicating this. So we have to say go to page number 50 and see this position. Okay, when we are going to discuss the pipelines, I'll show it to you there, then it will be more clear to you. Okay, so this type of indications you will always find in the diagrams, which are like page and the connection number or the pipeline number. Okay, these are the ship's particulars that you will find always in your vessel, that is not of the relevance in our pipeline diagrams. So they are basically discussing about the vessel dimensions, what is the length between perpendiculars, breadth, molded breadth. So this vessel is having 230 meters of length between perpendiculars is 223 meters. Then there is the breadth of the vessel width, the depth. Okay, design draft is this much, 11.7 and 12.1. so these are all as per the requirement. Okay, they have mentioned the tank capacity, cargo capacity, bunker tank capacity. Okay, now we come to our important discussion on this symbol list. Okay, so this is the discussion on symbol list in the pipeline diagram. Okay, so as per the classification, they have divided the symbol list into pipe and pipe joints, control and regulation parts, valves and cocks, pipe fittings, and control and instrumentation. We'll do it one by one. So first discussion will be with the graphical symbols on the pipes and pipe joints. Okay. Okay, so these symbols were devised to signify them what is their so whenever you are reading the pipeline diagram, when you see this symbol, that means the name here given. Okay, I'll show it through a photo representation also, how does this symbol look like. Okay, so that you have a clear idea about, when you see this in the pipeline, you can know what exactly it will look like when in the when you are seeing the engine room. Basically, when you are especially when you are a junior engineer and you are going to trace the pipelines in the engine room, the first job you are given when you join a vessel is to trace a pipeline. Okay, so when you have these ideas about the symbols, it will be very easy for you to locate actually what the pipeline looks like. Okay, or the symbol looks like. Okay, so let us go to the first symbol. This is the symbol of pipelines. Okay, so you can see there is a single pipeline passing and it is not being connected. Okay, you can see so we'll take a different color for this. You can see other pipe is not touching the pipe which is crossing. So this is, pipes are crossing but they are not connected. So this must be different pipes. So this pipe may be of bilge line and this pipe may be seawater line. So because they are passing nearby and the pipeline diagram has to show them in vicinity and they are not being connected, so there will be a gap between the two pipelines. So whenever you see a gap, that means the pipes are not connected. Okay, let us see the second one. Okay, so I'll show it to you through a photo also, how does they look like. The second one is connected crossing pipes. Okay, so what, say, similarly to the first photo, you see the second photo, you don't have a gap in between the two pipes. Okay, the pipes are connected like this, so this will be a common pipe. Okay, maybe this is a seawater line or a bilge line or a fuel oil line or whatever line it is, but they are common lines. That is why they have been branched like this and they are connected. Pipes are connected, so flow may be coming from here going to this direction also and this direction also and this direction also, branching for the other directions also. So they are, that is why they are connected. So they are not separate lines, they are common lines. Okay, similarly the third one you can see, this is a branch pipe. So branch pipe, basically why we have shown this one, why they have shown this one, say there is a main seawater line in this one. Okay, this is a bigger line, and then you have to branch a small section from this to some purpose, some auxiliary purpose. Okay, say the line is going to a cooler or somewhere in the engine room, so the pipeline becomes smaller there and is being branched out for some other purpose. So that is why you use a branch pipe. So branch, like a tree has got a branches, right? So major, the trunk is having the major trunk and then it has got the branch connections separately to branch it out to a longer say for other purpose or for long service. So they send it to through the branch pipe. We are using the flow in some other purpose. Okay, other purpose, or say branching it for say longer uses. Okay, now let me show it to you through the photos, how they look like. Okay, so if we see this in this photo, what we are seeing is three pipes that we have discussed right now. Okay, first coming to the not connected crossing pipes. Okay, so here in this diagram what we see is say this pipe is of separate purpose and the other pipe coming from the top is of separate purpose. So these pipes are not connected anywhere. So when you see like these pipes in the engine room, you can call them not connected but crossing. So they are crossing nearby and they are not connected. And how they will be indicated? They will be indicated by a dash. Okay, they will be indicated with a dash. Second one is connected crossing pipes. So in this one we can see connected crossing. So we can see this this pipe is coming from one valve like this, and then it is connected here, and then it is crossing. Okay, crossing here, or it can go maybe in this direction also, but in this one we can see here say this pipe is coming from one direction and it is crossing over to the other direction. So this is connected and crossing, connected and crossing pipe. Okay, this one maybe you can see this is coming from one direction, connected here. So these are common lines. I mean, this is only dedicated for this line. So only when this pipe will be connected when they are of common use, say only for seawater, only for bilge, only for any specific purpose. Third one is the branch pipe. Okay, as we can see here, this is the branch pipe, the lower one. So this one you can see branching here. So we can see this is the, say this may be a lube oil line. Lube oil is flowing there and you are using one small branch for any specific purpose. Okay, or say maybe the oil is coming from some other place and joining this main line. So this is a branch, small branch. Okay, so when the pipe is say branched out, or say reduced in diameter, or changed in the section to use it for other purpose or to send it for further usage, we are using a branch pipe. Okay, so these are the three pipes. Okay, now further, flexible joint or flexible joint pipe. Why do we use flexible joint? So say there is a pressure pipeline, say hydraulic oil line, 200 bar pressure. Okay, so in that pipeline you will find at places there are some flexible joints given. Why they are given? Because to accommodate the pressure fluctuations in the line, there are some flexible joints given in certain areas in between the lines. Otherwise what will happen, say when the line gets over pressurized, because the lines are design pressure tested for the same job, but in case say there is a any valve is closed in the line, or say there is a blockage in the line, the hydraulic oil will rise in pressure. Since it is not compressible, what it will do, it will try to rupture the pipe. So for accommodating that kind of pressure fluctuations or certain scenarios like this, there have been at places these flexible joints are provided. Okay, so they are shown by this type of indication. Okay, second is flange joint. This is very common. All the pipelines in the engine room you will find this kind of zones. It is shown like this. Okay, symbol for the machine connection flange joint. If there is any two flanges are used to join two pipes. Okay, so by the bolts, so this will be a flange joint. This is a most common joint. Always two flanges will be used to join the two pipes. Okay, so this connection is called flange joint. Okay, the third one is a reducer or expander. Okay, so the reducer will be shown like example is given here. This will be shown like this. Okay, okay, let me show. Okay, so this one is the reducer. So why it is shown like this? So what reducer means or the expander means that the diameter will go on reducing. Okay, or from the other side of the flow is the diameter is going to expand. So it is like a convergent divergent nozzle. Okay, where the say convergent part, it is going to converge into smaller section. So this one, so this is a reducer. You can see it in the pipelines, mainly seawater pipelines. When you will have bigger pipelines, say this is 150 nominal dia or 250 nominal dia, and then you are branching it for any auxiliary purpose, taking it into a smaller section, then it will be say 125 nominal dia, then it will be used with a reducer. Okay, what this reducer will do? So reducer will basically reduce the amount of flow that is going into this pipeline. So through this reducer, a smaller amount of say fluid will flow through this line. Say what seawater or fresh water, etc. will flowing through this line. So basically reducing the area. So if the flow rate is here, so pressure will also, so when you reduce the area, pressure will increase in this section. Okay, you have 3 bar here, so maybe here it will be 4 bar. So by reducer, you are using the reducer to increase the pressure on this other side. Okay, thereby pressure increases, velocity also increases. Okay, in this section. So there is a reducer or expander. Third is a sleeve type expansion joint. Okay, sleeve type expansion joint is where will you use sleeve type expansion joint? So when in case we are using any high pressure pipelines like steam lines or like hydraulic lines also, where there will be a sleeve where it will join the two pipes, and because of the sleeve, any expansion, or say mainly in the high temperature where you have high temperature fluid moving like steam moving, so in that case if the pipes will expand, they are going to maybe join together. so their sleeve is given on top of it. So in that case, the pipes are not able to join, or say they will expand but they will not join together. So that is why sleeve is given. Okay, this is sleeve type expansion joint. Let me show it to you. These were the other pipes. Okay, the second one is flexible joint. So as we can see, this is the flexible joint. So maybe in the hydraulic pipeline, you can see this, there is a bellow inside. Say rubber joint is there. So these kind of joints are given to accommodate any vibration or any pressure pulsations in the lines. That is why you are using a flexible joint. Okay, they are shown like we have discussed before. Then comes the flange joint. This is the most common joint. Like there are two flanges, and these two flanges are used to join two pipelines. So these are the flange joints. Okay. The third one is the reducer. You can see it is shown like concentric reducer, eccentric reducer. Eccentric reducer is not having the same same diameter change in diameter. In the concentric reducer, you will have a uniform change in diameter. This is the concentric reducer. Mostly you will find it in the seawater pipelines. Okay, to reduce the diameter and increase the flow rate, increase the velocity and pressure. Okay, these are the concentric reducers. This is why I am explaining it through a photograph, so that when you see it on board, you can directly visualize that, okay, this was the one thing that was explained in this pipeline. So this is the reducer or expander. Okay, reducer or expander. Now we had discussed the sleeve type expansion joint. Sleeve type expansion joint. Okay, so the first one here, you see, this is the sleeve type expansion joint. Okay, so you can see there is a sleeve here and a pipeline is passing. You can see reducer here also, reducer here. So when you are giving the pipe, say going to a pump, etc., then the seawater, mostly in the seawater pumps, etc., you will find this one sleeve is used, and it is sent into the reducer is used, and the flow is sent into the pipelines. Okay, this is the sleeve joint. Sleeve type expansion joint, given basically to accommodate for the pressure fluctuations. Okay, so pipeline is inside and there is a sleeve given outside. Okay, so until then, in the next video we will discuss about the other pipelines and fittings, and so thank you for this.